Okay, in this next review problem set, we're going to review some of the algebra that you'll have to be able to do in the context of problems during the course, but also to give us a chance to talk a little bit about function notation and some other things that you may have forgotten from your previous classes. It will be under homework again, and this time the factor FOIL review, and you'll see several questions there, and I'm just going to do examples of a couple of them. So the first question I want to show you has to do with some terminology about polynomials, and in general some terminology about functions. When we see this, the notation f of x here, pen over here. So the f of x notation, remember the x refers to an x-coordinate on a graph, and f of x would be the y-coordinate. So f of x, the number that comes out of a function, is the y-coordinate that goes with the x-coordinate of x. So when we want to know something like, well, let's say, for example, the x-intercepts. An x-intercept is where the function crosses the x-axis. Now, the x-axis on a graph is the same thing as just saying where the y-coordinates are 0. So the x-axis and the y-coordinates being 0 mean the same thing. So if I want to find out the x-intercept, what I'm really doing is saying f of x, the y-coordinate of my graph, needs to be equal to 0, and I'm going to find the x's that do that. So if f of x equals 0, that means we have x minus 3 times x plus 6 times x minus 2 equals 0, and we want to solve that. Now, this is a polynomial equation that has already been factored. The reason that we like to have a factored equation is that if you know with the real numbers, if the product of a bunch of numbers is equal to 0, then one of these numbers has to be 0. So the only way, the only way you can have a product of three things equal to 0 is if one of the three things is actually equal to 0. So we get to take the equation that originally had 3 terms in it and turn it into 3 statements that are all very simple. So here we'd have x equals 3, or x equals negative 6, or x equals 2. So those would be my x-intercepts. Now the y-intercept, on the other hand, is a lot easier because the y-intercept means where you cross the y-axis, and the y-axis corresponds to x having a value of 0. So if you want the x-coordinate to be 0, well, the x-coordinate is what you put into the function, so that's the x-coordinate. So if I put 0 in for the x-coordinate, then f of 0 will just be minus 3 times 6 times negative 2. I'm just putting 0 everywhere I see an x, and when you do that, you'll get 36. So that's the y-intercept. Notice that a function can only have one y-intercept, because when you put 0 in, you have to get a single number back out. The last question on here is the degree of the polynomial. That's just the highest power of x if this thing were completely multiplied out. And if you remember your FOIL method, where you take something from each term, you can see that there's going to be an x from here, an x from here, an x from here. That'll make an x cubed term, and there's not going to be a bigger x term than that. So the degree of the polynomial will be 3, and you find the x and y intercepts as the thing is shown. Now, to get the factored form itself requires a lot of practice. We won't see some really tricky factoring problems in this class, but you will have to be able to do basic factoring. So the steps for basic factoring are: step 1, to factor out the largest common multiple of all the individual terms. So in this case, there's a 4 that can be factored out of all the terms. So this would be 4 times 3x squared times 5x plus 2. And then we have to factor the part that's in parentheses. factoring, generally, I wouldn't worry about remembering a whole bunch of rules and tricks for doing this. I would just try to make sure that you're so good at doing FOIL to multiply things out that you could sort of work backwards. So for example, we know that if we did FOIL to this expression, we would have to have a 3x and an x in order for the first terms to multiply together to be 3x squared. Right? This should be the f in FOIL. Similarly, the last thing in FOIL here, the L, is a 2, and so the numbers that go here have to be 1 and 2. The only question is I don't know which order they go in. The tricky thing about FOIL, of course, is that the outer and the inner terms together are going to add up to this guy. So we might have to play a little bit of trial and error here, but realize there's only two possibilities. This is either 1 and this is 2, or this is 2 and this is 1. So it doesn't take that much time to try them both out, and this will be the one that works. And again, I would make sure you could check this by FOIL. The outer term here is 3x times 1, which is 3x. The inner is 2 times x, which is 2x. 3x plus 2x is 5x. So I've set up my first term to be right and my last term to be right, and then just by trial and error figured out what the outer and inner have to be in order to add up to 5x. There are a couple of special cases that people sometimes forget about that are tricky unless you kind of put them at the front of your head as special cases. This is the most common one. These guys, this is the difference of two squares. So 9y squared is 3y squared, and 16x squared is 4x squared. So from a factoring point of view, we still are factoring this as if it's FOIL, but because there's just two terms there, that means that the outer and the inner terms are adding together to be 0. So that's why we don't see any other terms in this expression. The nice thing is that if we see these really are squares, then the only possibility to get the outer and inner terms to add to 0 is if you have 3y as your first times first, so 3y times 3y, and 4x and 4x are your last times last. Now there's a minus sign here, which is significant, so one of these needs to be positive and one needs to be negative. And if that happens, then if you were to check with FOIL, you would see that the inner term is 12xy and the outer term is negative 12xy. And so you do get the outer plus inner term equal to 0 in that case.